Hello everyone. In this session, we will try to discuss about the pump theory of the positive displacement pump and also different types of pumps what we are using in the case of the fluid power systems. The first thing is nothing but with respect to the pump theory. Now here in this case, the pump operates on the principle where by the partial vacuum is created at the pump inlet due to the internal operation of the pump. This allows the atmospheric pressure to pushes the fluid out of the oil tank and into the pump intake. The pump then mechanically pushes the fluid out the discharge line. This action can be the best described with reference to the same. Now here, as the piston moves to the left side, the partial vacuum is created inside the pump chamber that holds the outlet valve in place against its seats and induces the flow from the reservoir that is at the higher pressure. Now as the flow is produced, the inlet valve is temporarily displaced by the force on the fluid and permitting the flow into the pump chamber, which is nothing but a suction stroke. When the piston is moved to the right, the resistance to the valve causes the immediate increase in the pressure that forces the inlet valve against the seal and opens the outlet valve, thereby permitting the fluid flow into the system. If the outlet port is open directly to the atmosphere, the only pressure is developed is one required to open the outlet pressure, which is nothing but the delivery stroke. The schematic diagram shows the theory for basic theory with respect to the how the pump operates. Now here in this case, what we are considering is nothing but the cylinder and as well as the piston mechanism. Once if the piston starts moving to the left side, the suction is created. Once if the suction is created, the inlet valve is open. Once if the inlet valve is open, the fluid is flowed from the reservoir to the chamber. Now once if the piston starts moving from left to right, the compression is taking place, which is nothing but something like what we can say as a delivery stroke. In that, the inlet valve is under closed position and the outlet valve is under open position. The fluid which has been collected inside the chamber is pushed to the outlet and the fluid is evacuated or expelled out from the chamber to the system. See, this is a principle normally which has been adopted in the case of the reciprocatory pump. The next topic what we are discussing is nothing but the classification of the positive displacement pump. As the positive displacement pump are classified as the gear pumps, vane pumps and also the piston pumps. In subdivision, the gear pumps are classified into external gear pumps and as well as the internal gear pumps. The vane pumps are classified as the balanced wear pumps and as well as the unbalanced wear pumps. The piston pumps are classified as axial type and as well as the radial type. The first what we are discussing is with respect to the gear pumps. Now the gear pumps are less expensive but limited to low pressure. It is noisy in operation than either the vane or it may be the piston because of the gears which is running at high speeds. The gear pump is invariably a fixed displacement type, which means that the amount of the fluid displaced for each revolution of the driving shaft is theoretically a constant. The first what we are discussing is nothing but the external gear pump. The external gear pumps are the most popular hydraulic pumps in the low pressure range due to their long operating life, high efficiency and as well as low cost. They are generally used in the simple machines. The most common form of the external gear pumps is as shown in the figure. It consists of the pump housing in which a pair precisely meshing a gears runs with a minimum radial and as well as the axial clearance. Now here the schematic diagram shows the external gear pumps. This external gear pumps consists of the casing. Inside the casing, the two gears will be there. The two gears is nothing but one is a driver gear, the another one is nothing but a idler gear. The driver gear is mounted on the shaft. The idler gear just it is a rotating member inside the external gear pump. As the driver gear starts rotating it, even the idler gear is also starts rotating it. Because of the what we can say the section which has been created between the teats because of the rotation that inlet from the inlet the fluid is flowed to the outlet. The force is generation on this shaft is generated on the shaft from the outlet pressure. Now once the gear, one of the gear is called as a driver gear, the another one is called as a idler gear. The driver gear is connected to a prime mover. The another gear is nothing but the idler gear, just it is a supporting member, or it is also called as the follower. As the teats of the two gears are separated, the fluid from the pump inlet gets trapped between the rotating gear cavity and the pump housing. The trapped fluid is then carried out around the periphery of the pump casing and then delivered to the outlet port. The teats are precisely meshed gear provides the almost a perfect sealing between the pump inlet and as well as the pump outlet. When the outlet flow is restricted, the pressure in the pump and the outlet chamber builds up radially and forces the gear diagonally to outward against the pump inlet. When the system pressure increases, the imbalance occurs. The imbalance increases the mechanical friction and the bearing loads on the two gears. Hence, the gear pumps are operated at maximum pressure ratings. The advantages of the gear pump, as we know that the main advantages of the gear pump is it is nothing but a self priming. They gives the constant delivery at a given speeds. The gear pumps are compact and as well as the lightweight. The volumetric efficiency of the gear pump is little higher when compared to the other pumps. The disadvantages of the gear pump: in the case of the liquid to be pumped must be clean, otherwise the gears will be damaged. The variable speed drives are required to change the delivery. If they run dry, parts can be damaged because of the fluid to be pumped is used as a lubricant. Even if the fluids what they are using is of the contaminated, then it is very difficult to pump the fluid from the inlet to the outlet, because of the as the fluid starts moving through the gears get damaged. The next topic what we are discussing is with respect to the internal gear pumps. The another form of the gear pumps is nothing but the internal gear pumps. The internal gear pumps, which is illustrated, consists of the two internal gear. One is something like a planetary gear, the another one is the rotary gear. The external gear and as well as the internal gear will be there. This gear is also called as the crescent gear. The crescent gear, which is placed in between these, acts as a sealing between the section and as well as a discharge soak. The schematic diagram shows the internal gear pump. This internal gear pump consists of the casing. Inside the casing, the two gears will be there. One is the crescent gear. The another one is nothing but the rotary gear. See, the in between these two gears, a crescent shaped gap is maintained. Because of that, that gap and also the rotation of the gears, the suction is created at the inlet port, and the fluid is carried from the inlet and it is passed to the outlet through the outlet port. When the pump operates the external gear drive, the internal gear and the both gear rotates in the same direction. The fluid fills the cavity formed by the rotating teeth on the stationary crescent. Both the gears transports the fluid through the pump. The crescent seals the low pressure pump inlet from the high pressure pump outlet. The fluid volume is directly proportional to the degree of the separation of these units may be reversed without difficulty. The major use of this type of pump occurs when through the shaft is necessary as in an automatic transmissions. These pumps have a higher pressure capability than that of the external gear pumps. The next topic what we are discussing is with respect to the vane pumps. In the vane pumps are classified as the two types. The first one is nothing but the unbalanced vane pumps, and the second one is nothing but the balanced vane pumps. In the unbalanced vane pumps, it is being classified as fixed displacement pump and as well as the variable displacement pumps.